Hey everyone, today we're going to look at a course to steer problem to leave a buoy abeam at a certain distance. Someone sent me this question into bluewaterbasics@gmail.com looking for some guidance, and I'm happy to sit down and provide whatever clarity I can. If these videos help you in any way, please like and subscribe. So I'm going to start with a visual at the bottom. This isn't going to be to scale, obviously, but it is going to hopefully offer a better visual, because on the actual plotting sheet itself or the maneuvering board, things can get a little bit tight. So step one is to plot our initial course, 340. We next want to plot the buoy. Our buoy is 342 at a range of 4.8 miles. It's gonna look something like this. 342 at 4.8 nautical miles. Step three is to find the difference in time from our starting point and our course change. So that's going to be 1422 to 1428 is 6 minutes. Step four, using the speed, we want to calculate the distance traveled from time one to time two, that 1422 to 1428. So 6 minutes times 14.8 knots is going to yield us a distance traveled of 1.48 nautical miles. Step five is to take that distance traveled and mark that on our initial course. Why? Because we're going to be on a course of 340 until we make that course change. 1.48 miles, we can call it right there. Number six is to, from the buoy, draw a circle at the required distance we want to leave it abeam. 1 nautical mile, and that's given in the problem. We'll be using our dividers to provide us some scale. Step number 7 is from our mark, from that distance traveled to our course change, we'll draw a straight line tangent to the circle on the desired side. So we want to leave this buoy abeam to port, so we'll draw our line on the starboard side of that buoy. Now, we have a course that's lined up with a number on the outside, but this is not accurate because it is not transferred to the center of our maneuvering board. So we'll transfer this line for step 8 to the center, out to the edge, and step 9 will be to note this course. So that's what this problem is going to look like. I'll try and do it as best I can on a maneuvering board right now. So it's going to look a little bit bunched up because the scale is a bit hard to portray accurately on here, but we have an initial course of 340. Be as accurate as you can. We always want to label everything. So this is 340. We want to then plot our buoy. Using our dividers and the scale on the bottom left-hand side, I'll measure out 4.8. It's about there. I'll measure that from the center. Draw a small arc. So now this line follows a distance of 4.8, and we then want to mark where that buoy is. So we have the distance of 4.8. We want to measure the angle of 342. Along that line, that 4.8 nautical mile line, I'll draw a dot for my buoy. Our buoy is 4.8 nautical miles at a bearing of 342 true. Now we want to find the difference in time 1 and time 2. We did that in the original diagram, but I'll do it here. 1422 to 1428 is 6 minutes. We'll then take 6 minutes, this is step 4, times our speed of 14.8 knots for a distance traveled of 1.48 nautical miles. Step 5 is to mark that distance from the center. So again, I'll take my dividers down to the bottom left scale and measure out as close as I can to 1.48. That's good right there, and we'll mark that from the center. 1.48 from the center. Let's call it about there. I'm going to make a mark for that 1.48. This is where we're going to make that course change. Step 6, from the buoy, draw the distance required abeam. We want a distance of 1 nautical mile. So again, with the dividers, bottom left scale, get as close as you can to that 1 mile. We will draw the circle around that buoy for that 1 mile mark. Our step number 7 is to, from our mark of 1.48 nautical miles, draw a line tangent to the circle on the desired side. Again, like the visual before, we'll take a line from the mark, tangent to our circle. We're leaving it to port, so we want it on the starboard side of the buoy. So that looks good. Now, this is not from the center, so this is inaccurate. We want to, using our triangles, transfer that course change line that we just solved for to the center. So what I have is, now it's transferred to the center, we can note this course. It's a little bit inaccurate because our scale is small, but that looks like 0.5 degrees true. We'll look at our answer choices. Our closest answer choice is D001, and that's going to be the correct answer.